This video is on the Doppler effect and how to solve these problems. A lot of students struggle with these and they make mistakes because they don't know whether to make the velocities positive or negative or whatever. I'm going to show you an approach that always works no matter what. I'm going to pick a frequency. Let's say the frequency that the source is producing is, say, 500 hertz. We're going to let the detector velocity be at, say, 40 meters a second. And we'll let the velocity that the source is moving, we'll make that 30 meters a second. Now we're going to assume the speed of sound is, I need to do this too, I don't want you to get confused with the source. This is source, this is sound, and we're just going to make it 343, and we'll assume it's 20 degrees Celsius. Now again, if the temperature is going to drop, this is going to drop at 0.6 degrees Celsius for every drop in temperature. It will go up also. If you say it's 21 degrees, say the temperature is 21, this would be 343.6. Alright. Okay, this is what I'm always going to recommend. You always, no matter what, put the source on the left and put the detector on the right. Okay, now go ahead and draw some vectors here. If the source is moving toward the detector, draw your vector this way. And this is the scenario where the detector is moving away. So in this case, source is moving toward the detector, detector is moving away from the source. If this is the case, all you're going to do is put in the values. The detector will hear this frequency would be 500. You're going to multiply by 343. Now if this scenario is stated as this one, if the scenario looks like this, it's going to be 343 minus the detector over 343 minus the source. And that's all you're going to do in this case. This is when the source is moving toward the detector and the detector is moving away. Now let's change it. Let's say the detector now, or let's say the source is going the other direction. Say the source is moving away from the detector and the detector is moving away from the source. Let's go ahead and put the velocities in here too. This one we said was 30, and this one we said was 40. Okay, if this is the case, all you're going to do is you're going to make this one minus. Now what's going to happen is your equation is going to change slightly, and you can make that, just add it, but I'm going to do it this way to kind of clarify things. You always subtract, but now this is going negative, so you put negative 30. You leave this one as 40. This out, and this would be your equation. So your equation would just be this: 500 times 343 minus 40 over 343 plus 30. And again, that's what you're going to do when the source is moving away from the detector and the detector is moving away from the source. Now, no matter what you do not put the source on the right side of the detector, no matter what the problem says. Just recreate the problem based upon the text and always have the source on the left, detector on the right. Alright, now let's change it. Go through all the scenarios so there won't be any misunderstanding here. Let's say we're going back this way. In this case, the source is moving away from the detector is moving toward the source. All you do again, boom, make that negative, and all you're going to do right here is change that. In this case, 343 plus 40 over 343 plus 30, multiply that by the 500, and you will get the frequency the detector will hear here. And then the only other one would be if the source is moving toward the detector and the detector is moving toward the source, then the only thing would change here would be you would get rid of this negative here. You go back to the problem here, and you subtract, and you're done. And again, that's all you got to do. You cannot mess these problems up if you follow this approach. Let's look at one problem here. Here you have an ambulance. It's coming toward you at 115 kilometers per hour. The frequency of the siren is 512 hertz. The air temperature is 0 degrees Celsius. What frequency you hear as the ambulance approaches you and after the ambulance passes you? Alright, well, you're going to have to convert this to get it into meters per second. So we'll do that first. So 115 kilometers per hour. Okay, we got kilometers in the numerator. I'll put it down here. 1 kilometer is equal to 1,000 meters. In this case, the kilometers will cancel out here and here. Now we're down to we got everything in meters. Now let's get rid of our hours. We got hours in the denominator. So I come up here. I put 1 hour here. I put 3,600 seconds down here. And again, if you want, you can go from hours a minute and then minutes to seconds, but this is faster. Run that number there, and you're going to get that. Now I'll grab the calculator. I'll calculate what that is. I'm going to get 115 times 1,000 divided by 3,600, and that's going to give me 31.94. meters per second. Okay, we also got to change the speed of sound. So we're 0, so we're going to do the velocity of sound. It's going to equal to 343 minus 0.6 times the change, which is 20. That's going to give me what? 12. That's going to give me 331. Hopefully I did my math right. Would be the speed of sound at 0 degrees Celsius. Okay, so again, let's go back, and we're going to, first thing we're going to do is we're going to draw our circles. This is going to be the source. This is going to be the detector. All I got to do is come down here. I put my source here. I put my detector here. Okay, now let's read the problem. As the ambulance approaches you, so the source is creating a 512 hertz. The ambulance is approaching you, so we draw the vector here. Okay, and we go ahead and put our velocities in at 31.94. The detector in this case has no velocity, so all we have to do is say the change that to frequency. Sorry about that. The frequency the detector will hear is going to equal to the hertz, which is 512, times 331, and you can say minus 0 if you prefer, it's not moving, over 331. Now this is going this way, so we're going to just subtract, because you always subtract. Here you're subtracting a positive number because everything's going to the right. We run that number, and let's see what we're going to get. We're going to get 331 divided by, in parentheses, 331 minus 31.94, close parentheses. We multiply that times 512, and we get a frequency in this case of 566.7. So my frequency the detector would hear would be 560. I'm just going to make it 567 just to keep things simple, hertz. Alright, now it says after the ambulance approaches you. So let's think about what's changed. Let's move this out of the way. So again, this is my hertz, and I want to make sure don't think it's velocity. Now as the ambulance passes you, the source is going back. So all we're going to do in this case here is we're going to change the vector, and we're going to go, we're going to change the vector, and we're going to go back the other way. So we make, if I can make that the other way, we're going to grab this, we're going to move it over here. But now I'm going back the other way, so all I'm going to do is make this a negative. Now, when I subtract 331 minus a negative, it's going to just be this. I'll put a plus, and I'll do it in red so we don't get confused. And again, all this thing is changes. Now I'm adding. So let's run that number there. In this scenario, in part B, it's going to be the frequency the detector is going to hear is going to be 512 times 331 minus 0 divided by 331 plus 31.94. I'll run that number, 331 divided by, in parentheses, 331 plus 31.94, close parentheses. Multiply that by 512, and we get a frequency of 467. which makes sense. As an ambulance approaches you, you're going to have a higher frequency. As the ambulance passes you, the frequency will go down. Hope this helps. Again, always follow this approach. Source on left, detector on right. If velocities go to the right, you make them all positive, which means you subtract them both. If velocities both go back to the left, you subtract a negative, which means you add them. All right, best of luck with this.